Hello and thank you for joining me in this video on thunderstorms. We are working our way through thunderstorm hazards. On my YouTube channel, you can see all sorts of hazards associated with thunderstorms. But right now, we are talking about convective wind shear in this video. And we've already discussed in other videos weather producers of convective wind shear as well as strategy, inadvertent encounters, and also the model of flight crew actions. In this video, we'll discuss the detection of wind shear, convective wind shear, and also the alerts that are issued by air traffic control. There are several different types of technologies that are used to detect convective wind shear at airports. We're going to look at the low-level wind shear alert system, the terminal Doppler weather radar, and then finally the airport surveillance radar weather systems processor. The low-level wind shear alert system, or LWAS, is a ground-based system that's composed of a network of anemometers. Depending upon the type of airport and the number of runways, it can be up to 32 remote anemometers around the airport. And these anemometers are located strategically around the runways to provide detection for wind shear. And specifically, they're looking for microburst and gust fronts. There is an algorithm that calculates the vector difference between the winds at each site, each anemometer, and if it exceeds a certain value, the wind vector shear, then you'll get a wind shear alert in the control tower, which air traffic control will pass on to pilots that are taking off and landing at the airport. The terminal Doppler weather radar came about in the 1990s, early 1990s. It's funded by the FAA. It's a C-band Doppler radar that's designed to detect microburst and gust fronts. Typically, these radars are located 9 to 12 miles from the airport, so they're scanning above the airport, both the approach and departures, and they use a very high resolution fine beam, radar beam, to look for microbursts and gust fronts. There are 45 TDWRs operational across the United States. Typically, you'll find a TDWR where you have a large amount of air traffic and also lots of thunderstorms. So you can see on the East Coast and Southeast, there are a lot of TDWRs. But on the west coast of the United States, where you don't see many thunderstorms, although they do have a lot of air traffic, there's not many thunderstorms, so you don't see a lot of terminal Doppler weather radars. These radars are very short-range radars. They have their best resolution out to about 55 miles, so they don't look out very far, just over the airport. Another type of technology that is used is the Airport Surveillance Radar Weather System Processor, ASR-WSP. The ASR-WSP, or just the WSP, is an airport surveillance radar, in other words, an ASR-9, an air traffic control radar, which is an L-band radar that has been modified to be able to detect precipitation and also to detect wind shear. So it has it's been modified to have some Doppler capability. Since it is an L-band weather radar, it does not have the greatest resolution, so it is designed to have wind shear detection capabilities at airports that don't have terminal Doppler weather radars. In other words, it's a poor man's terminal Doppler weather radar. TDWRs are very expensive. If there is an existing air traffic control radar, it can be modified somewhat to provide a little bit of wind shear detection. And that these have been deployed across the United States. There are 34 airports that have ASRs that have this capability. Next, we'll talk about the alerts that are provided by air traffic control. Air traffic control, specifically the control tower, will provide convective wind shear alerts for the departure and arrival corridors of particular runways that have wind shear detection capabilities. They'll do this for the 2-mile departure corridor and the 3-mile final approach corridor. And they do this within a half-mile either side of the center line of the runway. So if there is wind shear in these corridors, then the air traffic controllers will provide these alerts. The two types of alerts that they can provide are microburst alerts and also wind shear alerts. Microburst alerts are issued when there is more than 20 knot wind shear in the departure or arrival corridor that is protected by wind shear detection equipment. Here is an example showing a 35 knot change in airspeed on final approach. Specifically, the air traffic controls will issue this warning for runway 27 arrival. Microburst alert, more than 20 knots, of course, microbursts. A 35 knot loss, 2-mile final threshold wind speed is 250 at 20 knots. Here is examples of wind shear alerts. In this case, it's 20 knots or less, and this is on the final approach. Specifically, the air traffic controllers would announce runway 27 arrival, wind shear alert, 20 knot loss, 3-mile final, threshold wind speed is 200 at 15 knots. And here is another example where you may have multiple wind shear alerts. This is specifically for departure and arrivals, and they show a gust front coming through the airport. And this is how air traffic controllers would read this. They would say multiple wind shear alerts, runway 27 arrival, wind shear alert, 20 knot gain on runway, and runway 27 departure, wind shear alert, 20 knot gain on runway. The wind is 250 at 20 at the threshold. So that provides you a little bit of information about how wind shear is detected at airports and how air traffic controllers pass on that information. If you want more information about convective wind shear or thunderstorms, you can watch these other videos at my YouTube channel.